All right. Sorry for the delay there. Welcome to the stream. I'm Agent Ultra, and on this stream we do all kinds of programming. For the past little while, I've been figuring out how to build a multi-user dungeon server in Haskell. What that is, it's mud server is what people call it. It's like the precursor to massively multiplayer online games. It's text-based, but it's real-time. Multiple people connect at the same time, play the game at the same time. And things happen whether you're sitting there watching them or you're typing commands and like engaging with the game. So, yeah. We've been building in Haskell, learning about embedding Lua in Haskell applications, learning about the software transactional memory library, and supporting libraries in that ecosystem, networking in Haskell, and all kinds of fun things like that. So without further ado, let's jump into the code. We've been working on persistence in order to implement some of the Lua API that we're starting to expose to the game programmer. So yeah, let's get into that a little more. Alright, we have broadcast channel and login stuff, because I was gonna start updating the authentication code at some point so that we can register users and save them in the database, and authorization stuff and all that sort of stuff. Yeah, that's right. I think that's where we're at. Okay, so arranging some windows. All right. We got a user from the database. By username. Because we handle the login. We get the challenge result. Get a database handle. Read the connection from that handle. And then we lift the user out of the database. Update all success. Right. And I think I was just a little bit Murphy about not being able to do the database, any kind of database operation inside our STM transactions. But just like with the, if that becomes a thing that I need to be concerned about, I think we can do something like what we did for the Lua interpreter and add like a lock basically on it if we need to lock the database for important things. I mean, shouldn't be too much of an issue. SQLite does have that kind of stuff built into it. But, I don't know. Okay, and so let's run this server. Also get a database, sorry, a telnet, mud client up. Killed client is what it's called. Okay. Things are a little bit slow on the machine for a moment. I think the server is running. Connect. Yep. Good. All right. So register, say foo bar. Log in, foo bar. Ah, there we go. no such user exists because it doesn't exist in the database, right? We look it up from the database first. Users that we have in the database. Right, we started taking names from the audience last week. SQLite 3, Bakamud DB. Yeah, we had Bakamud. Awesome. Okay. Okay, good. Got a valid log, yeah, because I don't think we have passwords implemented yet, so I thought that would work. So that's river. Let's say invalid login. Is that me code? Is that me being silly? No. Ah, there we go. Okay, challenge. Right. Okay. That's why it fails. All right. So we're kind of there. We kind of left it in a half state. Okay. So let's fix that. I'll make a little work in progress committee commit. Course. Yeah. Next being a bit of a pain. That's not Emacs's fault. It's this sums up with this VM, and I've just never fixed it. I just keep putting up with it, which I should probably change. Yeah. There we go. Work of RS. Look up user from DB. Yeah, look up user from DB and handle login. This is probably where we should actually do the user lookup. We have accounts tvar here that looks up accounts. Register, I believe, implements that, adds to that accounts map from the server state. tvar.io, which is probably a map. Yeah. Okay. So yeah, I think this is probably why I didn't like the user type that we had. Should probably be account. And when we load an account, we should probably load it into this map. Yeah. Okay. So it's almost like this, except I just want to call it account instead of data, instead of user. And we should probably have account user pass and something else. Hey, Suki LaPlante, thanks for the follow. Yeah, great choice. Welcome to the stream. Are you a Haskell programmer by any chance, or curious? What do you do? Just like to watch programming streams? Nice. Nice. Love it. Okay, so I'm gonna improve this a little bit here. Nice. Well, I will do my best to please and entertain. Okay, so I have types for accounts and users and names and stuff like that. Never tried it? Ah, that's all right. Well, if you have any questions, feel free to, poke me. It's all good. I like diversions. Yeah, C++ is pretty cool. I like it too. I recently did some posts on my blog on trying to catch up on C++ 26 type stuff. Implementing things with it. Cool. Let's see. Where did I put them though? That's the thing. Save that. For some reason I'm putting the command. Okay. Just wrappers for text. Oh no! You're the code fixer. I haven't used any kind of code gen for C++ type stuff. Only because I find from like the C++, well, the code I've seen generated by LLMs for C++, like it's the kind of code that has like no obvious errors in it. Yeah, making it pretty and elegant is one way of preventing errors, in a sense, in a way. Like, it's not a direct way, but it is a way. It's a good thing to do. Because people need to be able to understand that stuff, you know what I'm saying? Okay, so I have some types here for passwords and usernames. Just they just wrap the underlying type, just so that we can like attach some behavior to them, so that we don't like reveal passwords, for example, in logs or debugging or anything like that. I'll probably want to also do like some hashing classes for these. Pascal, nice. That's a classic. I think I learned Pascal way back in high school. That was not very long ago. Okay, so yeah, I'm gonna bring those types out to their own module, because that's where they probably should be. I'll just cut them. I don't want if I want to put them in account, maybe I want to put them in account. It's probably a good place to put them, because that's where I'm going to be using them. Yeah, nice. What do you find simpler than what? Actually, you said simpler. Yeah, nice. Yeah, I do a lot of the Pythons and the JavaScripts. I mean, actually, well, for like 4.5 years I was employed doing Haskell type stuff, so I haven't done a ton of JavaScripts and Pythons in recent years. But, you know, still keeping up with it. Okay, I'm gonna get that. How do I close that? So you find C++ easier than Java. Interesting. Is it more like a familiarity thing, like libraries and stuff? Or is it like a semantic thing, like you actually find it easier to manage memory and lifetimes and move semantics and stuff like that in C++? Familiarity, yeah. Yeah, I get that. JavaScript's got like, or Java has a very big library, standard library. If you already know the C++ one, then yeah. Totally get it. Okay, so I move the usernames and passwords over here. It's, yeah, kind of a messy sort of thing. I think there's like a good language in C++ that's trying to get out. From watching the language over the years, decades really, they spend a lot of time bolting on a lot of features And I think they're starting to figure out what the language should be. It's just they have to support a lot of code that already exists. Yeah, and it won't, right? It has that that heritage of C as well. Like I do a fair bit of C programming, and C is the same thing, where there's like a lot of code out there that just, you know, backwards compatibility is huge, huge in that ecosystem, in that language. I mean, it's paramount even. So, can't get away from it. Alright, so I'm going to replace those plain text types with my username and password types, which are essentially just the same as text. But because I'm using new type, the type system picks up that as username, not just text. But for the purposes of like compiling the program and running it, there's no like boxing of like password under text. It's just represented as plain text. Like all the type stuff gets erased, which is kind of nice. Okay. And then I'm probably gonna have to implement to field and from field for those. I imagine, but I'm gonna get my builder working here. So GHCID compiles the code continuously, reports any errors to me, and I can fix them as I go. Okay, so I just cut out that code from that module, so that's going to be, all those names have to be returned to that module, so we'll just import it back in command. Okay, cool. Account.hs, and we got some things here. So 2-row. And then we'll probably need to add the field here. All right, so that's what I was saying here. Now GHC is telling me, like, I don't know how to turn this into a field. You got to give me a 2-field type class instance for this type. So that should be pretty easy. DB to field, username. Don't know what methods it's got on it. The biggest problem working with C++. Oh, your friends. I was gonna say, you have no knowledge of the computer internals, but you're doing the C++ cleanup. That's amazing. Yeah. I find that's unfortunately fairly common. I find it's fairly, like, I don't know, I do a lot of web development professionally, and I definitely know a lot of folks in web development who are excellent programmers, but yeah, they couldn't write C++ or C to save their lives. It's not their bread and butter, right? But one of those things that I kind of also fear about LLMs is that they give people the power to like generate C++. And like I was saying, it generates stuff that looks plausible, but isn't necessarily correct unless you could write it yourself and understand C++ fairly well. It's hard to detect bugs when you don't know what you're looking for, you know? So I feel for you. I feel for you, Suki. I feel. It's a rough job. I don't blame you. CMake is a nightmare. I hate CMakes with a passion. I generally dislike most build systems, to be honest. I think they are just a level of complexity that is like, holy crap. And it's kind of self-inflicted in C and like C++ case, but like you can be a lot more simple with it. Yeah. What do you think is the worst part of CMake though? The terrible part. To field on username. Bring up the documentation. Or import the module into a REPL. Browse it. Yeah, I mean, let's build systems in general, really. I mean, it's kind of self-inflicted in C and C++ because of the way, like, they decided to set out early on compilation units, and, like, their scope to files and stuff like that, translation units and stuff. Those boundaries are there. Also somewhat flexible too, like I could see why they did it the way they did, but then you do cross compilation and like different platforms, and yeah, it becomes nasty. So have you been using C++ 26 and like modules? Do they have modules? Yeah, I think it has modules, right? I don't know why the documentation is looking terrible at the moment. Packages might be down. Oh, it's undergoing maintenance. Oops. We just caught it at a bad time. Cloudflare seems to be having issues. Let's see. So this is the two-field class here. Yeah, every time I see CMake, I'm like, no. I just want to use make. That's it. You know. But like a lot of projects use CMake, so you gotta end up using it for a lot of stuff. Super annoying. What can you do? Okay, so you got two field, username, and then it's got to return a SQL data. Is that acceptable? Oh, I know. I also have to update the Cabal file. Speaking of build systems that kind of suck, the Haskell one's called Cabal, and it has similar issues. Not issues to CMake, I guess, but it's also kind of a pain in the ass sometimes. So every module that like is part of my library that I want to be, you know, make sure it's compiled, I gotta like add it to this list. And there are tools that can auto-generate your Cabal files, but then it adds yet another layer of complexity to things. Yeah. And it's one of those evergreen problems that, like, it's like catnip to developers, right? That's why there's so many build tools like Ninja and all these other ones that pop up. Someone somewhere goes, you know what, this sucks. And they build their own, and then there's 15 build systems. But that's how you get innovation sometimes, you know? So... Oh wait, auth is already... Or something that's already there. Oh, account. Account's where I put it. Yeah. Account. Yeah. You could do the build system in Python. Probably do one in Haskell, which is Book of Balls written in. Soding did one in C, so he compiles C with C. He had his own build system, which is kind of cool. Okay, so then I need DB2 field, which apparently is a separate module. So I need a function text to that. Let me get the larger. Is there anything in scope that could do that? Yes. There is such a function called db.sql text in scope that can do that. Or I could just call toField on it. Makes sense. Perfect. Yeah, there's got to be a CLI like background tool that you can use so that you can script and automate it easy. It's got to be. So field, password, similar. We need the similar, we need the mirror of those, the from fields. db.sql text, probably, right? Import it. Oh, db.field. Hmm. Okay, SQLite internal has the field type. Is there an external one that I'm supposed to be using? Field parser. There we go. From field, back. Okay, so I need a field parser in there from field. Okay, okay. parser is a field to... Okay. There we go. Okay. Oh yeah, I have a pretty... I kind of broke my mic stand a little bit, and I use a dynamic mic. It's like an SM58. Not super great for talking, especially if I'm not talking loud. Because it's dynamic, it doesn't pick up quiet. Yeah. But I'm reluctant to use a condenser mic. Because they pick up so much sound. That I'd be worried that you can get like every clicky, every breath, every mouth noise that I make. Condenser, yeah. It's a kind of mic that it takes like 48 volts phantom power. Like they're the ones people usually see, like streamers often use for talking and voices and like very sensitive sounds. Yeah, maybe I shouldn't be worried about it and I should just get one and use one. I usually use this thing for instruments and for like when I'm singing and stuff or on recordings and whatnot. Yeah, okay. Thanks, System Carl. And welcome to the stream, friend. I'll look into it. And Twitch TD, welcome. Okay, are there a bunch of field parsers that I can use? Or should I just use field data? Okay, so if I use field data like that, I now need to put in this hole here that I have on line 15, this underscore, I've got to put a function shaped like that. I'm wondering if there's maybe, we can look at the instances of these and see if there's like a better way of doing this. Like maybe we can fmap our constructor over db.field like that. Can I do that? Does that work? Almost. We couldn't because we want an okay. Okay. Let me look at the implementation for that. For some hints. Okay, that's how I should write it, basically. From field, SQL text, okay. Where's field? Or maybe types? Probably okay. Oh, field doesn't cover any of those. You re-export field here though, so I should have it. Although you don't export the constructor. Okay, just the type. Which means you probably don't want me reaching into internals to do that, because I bet it's like on the internal module. Oh well, tough. I'm doing it that way. So we go from field, db.field, SQL text. And then otherwise, we return error. TwitchDD, yeah. There are libraries like that that can do the introspection on the types to derive those instances for you. They probably use generics or template Haskell to achieve that. There's some ORM libraries that will implement those. I don't know if there's like a lightweight one that just implements that part that works with SQLite simple without doing the ORM thing. Because like these are all fairly straightforward and like automatable. Okay, return error. Okay, conversion failed. F. Also field F. Okay. Perfect. Although, if you're going to write custom types for your database fields, you're still going to have to probably write your two-field from main field stuff. You can make types aware of some of the runtime logic. Not all of it. Some of it. We'll just copy that there. Pop that there. Username. Okay. Then I can go over to state. Account. And server also moves it back. And we're all good. So a little work in progress committee commit for that. But now. Okay. Okay, so we can read and write usernames and passwords to our database layer. Awesome. Now I want to fix up the thingy. Server, we handle the logging, the challenge. Right. So challenge doesn't reach into the database necessarily. It's looking at the server state, which is holding a map in memory of all the accounts, which has like the usernames and passwords and such. I think challenge should take care of all this, including, you know, if it needs to go to the DB, go to the DB. If we have the account credentials cache, use those, and that sort of thing. Because right now, we're going to move the handle logic into that, because we should just have challenge result challenge here. But right now we got the DB handle here, which pulls up this stuff, gets the user's thing, and looks up the user, which probably should be in challenge, I imagine. Also, I want to order these because I'm just that kind of person. Okay, we don't need these, turns out. Okay. So we'll implement that in challenge. Yeah. And then I think we can keep all the complexity of that hidden behind this action. Okay, so let me just grab that code from handle login. Just setting my marks here so I can jump back and forth quicker. Yeah, I think what I'd like to do is like do a cache lookup kind of thing. Like if it's not in this map, this in-memory map, then go to the DB and look for it there, and do that kind of stuff, which I'll need to make like an interface. I might need to make an interface to do that. Maybe we could just do it straight in code, but I think we should do it like a little interface for or something. But I'm just going to make it work this way first. I don't want to like redesign an API for it at the moment. You know what I mean? Yeah. So we get the connections map, connection. We'll get the user from that. Okay, when we update the auth focus, we do have to give back some data here because we use it for setting the user ID on the auth state. Yeah. So I'll grab all that. So that gets the connection handle, gets the connection out of the STM variable, and then we call the database to get the user. And we have to return that user in the challenge, probably in the challenge result. So challenge success. User. Pop that here. Here. Did I grab too much? Probably grabbed too much. Okay, and then we've got 989, just a missing get user function. Interesting. Oh, that came here, so we'll just grab that. Here. Oh, yeah, we just have to that. Okay, cool. All right, so that compiles. It's not quite ready yet, obviously. Handle login. So now, challenge result handle supposedly handles the challenge, right? Gives us back a user in the success case. which we can use to update the user's authentication state. Okay, that part works. So let's go back to challenge now. Okay, so we're still looking up in the accounts TVAR here in order to do the challenge. But now, I'm going to maybe re-implement that. Maybe I should just re-implement that. Because I want it to now actually use the user object and like compare the user password. Now, I'm not doing any of the hashing yet, encryption. Well, encryption. Not doing any of the hashing and stuff yet for the password, but we'll get to that. I just want to get it to like use that database row to like check the credential, like do the challenge. So now that we have the user, we have an input username and password. We have the actual user from the database based on the user's username. That returns a maybe user. Could be wrong, but GHC will tell me if I am. Nope, I am wrong. Okay. So that function will probably log or something. Throw an error, I guess. Get user. Yeah, it'll throw an IO error. No such user exists. Yeah, it's maybe not the greatest, but we can assume the user exists here. So we just need to check if the password is equal. That would need a word. Challenge fail. Will that work? Maybe if that field was in scope. It's not that, it's account user pass. Right, it's not account, this should be account. Okay, that's the other part we gotta do. Switch it over to account. Username is still fine. Yeah. That's still all good. Change that to account. Right, so it shouldn't be user. Account in there. module. No, we don't use it to cast TVAR, at least temporarily. Okay, cool. Cool. Okay. Yeah, then we have to actually create the SQLite database. So let's do that. The table, at least. .db. Create table accounts. ID. Key. Username. Text. Password text. Okay, so we'll insert into accounts some values. ID 0. Sorry, for username, password. Again, unhashed, which is not the way you should do it. Alright, we're just in development right now. Drop table users. Quit that. Run the server. And then we should be able to connect. Log in. Cool. Okay, that's fine. We got a conversion, type conversion here. Because I misunderstood the primary key. I thought that would be inserted automatically for me, but SQLite, no problem. I didn't insert a generator for this primary key on the table as well. There we go. Cool. Alright, so it's doing the challenge from the database now, which is great. Plain text still, so we're going to fix that. And then it gets the list of the avatars associated with that user and displays them and stuff. And the callback from Lua, so that's going to Lua code. Lua code's calling our Haskell code through the API we're providing and all that good stuff. So, prog. Okay, so let's see. We're not going to do the caching layer stuff. Doing like right through caching to the database back up to the in-memory representation. But we will do, maybe we should do password hashing. Shata. So actually, let me create the little commit for that. A stage. Work in progress. Modify challenge. Look up accounts. Database. Probably need to get rid of the users module. Just get rid of that before I forget about it. Okay, package. We have some pretty good hashing libraries available to us. I think hashable. Hashable's the one. No. Sorry, that's something else. We might end up using that for our caching layer stuff, but no, we will need crypto hashing. We don't want a simple out of date hash. Decrypt bindings. The open wall C version of Decrypt is included in the package. Cool, that's definitely a good candidate. This is just a prototype, like a learning project. So obviously I want to do it kind of properly, but I don't want to like go overboard either. I don't need to. But when you're doing things for an actual like production server, obviously use the best hashing algorithm you can get away with. That makes sense for your application. And requirements. 0.0.11 Decrypt. Got builder running. Okay, that's too far ahead for me. 10. Okay, so that'll be part of, well, we'll have to update challenge to actually encrypt the password when we compare them. All right, we're gonna need salts. I believe. Cool, hashing policies. Okay, so you're gonna, so your hashing policy is great. call a validate password function. Cool. Sweet. Okay, pretty simple API. So we just need to call validate password, packing our thing into a byte, our password into a byte string. So this line here. So bcrypt. Crypto.bcrypt. Call bcrypt.validate password. So then we get the account password. And the input password, which we have to pack into a byte string. Control import qualified up here. Data byte string car 8. As B. This as well. So we need to unpack that. So I'm just going to add a little getter function. To be able to unwrap that. Then we can use that here, get password, and then I just need text to byte string. From data.text.encoding. then I can put in this hole the shape that I need. Text.encode UTF-8. Why does it think I need a char string? Oh, pack. Yeah. Maybe I need more like this. That would probably be the right, because passive text there as well. Yeah, car was not necessary. There we go. Okay. Okay. So that uses that. Now we need to, in order to actually make this work, I need to use the same hashing algorithm, obviously, to create the hash password. So I can't use the plain text one I've got in the database. So I need to implement register. Update register. So order progress. Decrypt. Password validation. To challenge. Keep and handle register. This could also do the write through stuff that I want to do eventually. We'll just make this write to the SQLite database, and that should get this story going. Because right now it just writes to that in-memory map, right? Okay, so we need the database handle. Comment that all out. Cover that as well. To handle login actually. No, I want to go to challenge. Let's do that. Accepted. Kind of want to do okay, but yeah, a little bit like that. So we get the handle, we get the connection out. In this case, our version of getAccount here is going to actually return maybe not error out if it doesn't exist. So if we have an account, return registration failed. Oh, we turned it, sorry, the old code used the result type. Here from the atomically, right, okay. So I can just do it. This. Using already in use. Try another one. It will be in a moment. Okay, and if it's not there, then we gotta do an insert statement there. Yeah, SQL inserts. How do we do the insert? Execute. Okay. How do I do simulate? It's been a while. Automatically auto increment. It's a keyword, right? Okay. Okay, so the auto increment keyword appears after integer primary key. That changes the automatic row ID assignment algorithm to prevent the reuse of row IDs over the lifetime of the database. Oh, what is the maximum ID? 60. Oh, it's a maximum of 664 integer, I think. Okay. Okay, so auto increment. Okay, so we need to just execute. Insert into accounts, username, password, values. We could just use question marks, I believe. execute named. I like execute named better. How would we do this? And then we do the list of those things. Password. Let's pass. We gotta hash that. We could hash that here, or we could hash that in the two-field instance of password. Put that like that. Oh, it's got to give the connection. And we lift IO that. Okay, then I'll put on there. That. Okay, the other thing I wanted to do is the hashing things. So here. Crypto.bcrypt. Okay, so the past will be a text, so we're going to have to encode UTF-8 to get our byte string pass, and then that's going to have to be imported. Encrypt that with bcrypt function. Hash password using policy. Oh, okay. Yeah, no, this isn't the way to do it. That's right. That would be bad. We need to hash pass. Called hashed pass. Hash the pass of the pass. Password, and we're going to get a Bakamud server. Password. And we're just gotta put a little constraint on here. Nope, we're just gonna make it audio. We're gonna pop it in there. Okay, now we call it bcrypt hash password using policy. Bcrypt slower bcrypt hashing policy. Oh, this keyboard. I'm for some reason not even know Okay, where's that exported from? Oh, jeez, that's annoying. Okay, then we need a byte string there. We have encoding, okay. Code UTF-8. Okay, and then return. Actually, we could probably just return constructor. No, that won't work because that'll be text. Let's just get the hashed. Hashed is a maybe. Okay. All right, just. Okay. Okay, so if it couldn't, what do we do? Just hashed. Gives us a byte string. Where is this hole come from? Oh, here. code UTF-8. That's just the password constructor. Okay, that's good. Okay, let's see if that works. No, SQL 3 first. We'll just truncate the table. Oh, we'll drop the table. If I could type, that would be great. Okay, create table, accounts, ID, integer, primary key, auto increment, username text, password text. Okay, now we run the server. Now we should be able to register a new user, save it, get saved in the database, and then log in as that user by checking the database, and the password should be encrypted at rest. So let's register Bakamud with foobar as the password. Registration accepted. Okay, cool. We should be able to log in as Bakamud. If we try foo, we shouldn't be able to. Invalid login. And if we try Bakamud foobar, we should get login. Okay, that's good. Now, let's just check our database. From accounts. Okay, we see the hashed password. Hash is salted for your convenience. Quite nice. Okay, so let's stage that as well. Okay, and rebase all of these. Okay, and what are we going to call this? Commit. Squash them all together. Reword that one. The main change is in Bakamud server. Added. Changed. Change modify challenge from lookup from database. Modify handle register. Save registration to database. Removed. Bakamud user. We also added the bcrypt. Let's see. Cool. That's about all the time I got for tonight, folks. So that's great. Got a start on the registration and authentication, kind of refactored to use the database. Next step, I think, will probably be to update make that a write-through cache, so that we write the account to memory after we write it to the database in case of register, and then try to read through from the in-memory database. And going to the database we need to when we're looking up the account. If we want to, or waffle on that and just drop it and just go right to the database and back for that. Not super important. But anyway, I'll think about it during the week. Thanks for tuning in, watching, and hanging out with me. This has been great. For those of you who are tuning in for the first time and watching for the first time, I do these streams once a week on Tuesday evenings at about 10 after 8 in the Eastern Standard Time Zone. So set your notifications and follow me here on Twitch to get automatic notifications when I go online, or just write it down and come back next week. If you're watching my VODs on my YouTube channel, I back up my VODs on YouTube there. You know what to do. Like, subscribe, thumbs up, all that stuff. Helps with the channel. And you'll get notified, of course, when I post new VODs. Go to declarative.tv above my head and check that out. There are lots of other cool streamers who are also looking for an audience, who would do things in declarative languages like Haskell, like Elixir, like Erlang, and others. You can also find a link to a Discord server there where we have a channel for this stream. So if you didn't get a chance to ask the question you wanted to ask, or you just want to talk about your projects, or you thought about something later, come hang out with us. Ask a question. We like talking about programming and all those sorts of things. And that's all I got for this week. So thanks again. May all your monads be free. May your types always check. And you should also follow me on the Fediverse on types.pl at Agent Ultra. The code for this, of course, lives on GitHub. Push this all up now at Agent Ultra on GitHub. And this is Bakamud. Let me just post that link for you there. Bakamud. Papa. Thanks again. Take care out there. Happy hacking. All the best.